Hello, I'm Ronya Çimen and I'm studying computer science in Bilkent University. In this video, I will be presenting my uniform circular motion experiment that I conducted for my Physics 101 lab project. The aim of my experiment is to observe uniform circular motion on an air table and to measure the angular quantities of this circular motion. I also aim to verify that without the string tension, there is not a net force that acts on the object, which confirms that the force known as the centrifugal force is actually not a real force that acts on the object. Theoretically, an object in circular motion requires a net force directed toward the center, known as the centripetal force. In my setup, this force is provided by the tension of the string. Additionally, Newton's first law states that if this net force is removed, then the object must maintain its velocity and continue in a straight line at a constant speed along the tangential path, since there is not a force that acts on the object anymore. These are the equipments that I used in my setup. In the experiment, the puck was tied to the string on the weight. After activating the airtable and setting the timer frequency to 50 milliseconds, I gave the puck an initial push to start the circular motion. Once the motion is stable, I cut the string to remove the centripetal force and recorded the puck's linear path on the same sheet of paper. This is the spark marks of the motion I recorded on the paper. Then I connected the center to the spark dots and measured the angular displacement of the puck from the spark dots using a protractor. Then I drew a line in the direction of the linear path and measured the angle between this direction and the radius of the circular motion. This is what the paper looked like after recording the data. After measuring the data, I converted the degrees to radians, filled the tables, and plotted the angular position versus time graph for the circular motion. From the slope of its best fit line, I calculated the angular velocity. By using these circular motion equations, I then calculated the tangential speed, centripetal acceleration, and the string tension which acts as the centripetal force. Then I filled the table with the angular quantities that I found. Next, I plotted the linear position versus time graph and found the velocity of the linear path from the slope of its best fit line. Even though Newton's laws predict the speed should remain constant, when I compared the velocities of circular and linear motions, I found an approximately 7.6% deviation in the speed and a 4.44% error in the angle between radius and the linear path, which theoretically should be 90 degrees. These deviations from the theoretical values resulted mainly from the measurement uncertainties and imperfections in the setup. Also, the plastic air tube attached to the puck applied a force to the puck during its motion. Additionally, air resistance and friction caused a slight difference in the puck's speed and direction during its motion. Therefore, the fact that the puck followed the path with nearly same speed with direction approximately tangential to the circle are consistent with the theoretical expectations. And the results demonstrate that with the lack of centripetal force in the direction of the center, the object's velocity remains constant. Thank you for watching.